Welcome everybody, my name is Bernhard Rümpfel. I'm an application engineer and trainer at Softing Automotive. Today I would like to show you how we can quickly program a diagnostic application using a function-oriented API. I'm going to highlight the benefits of a high-performance runtime system and look at our product, Softing SDE, the Smart Diagnostic Engine, including the Smart Diagnostic API. First, let's have a look at the traditional diagnostic system. At the top, we see the application, the diagnostic tester, optimized for development, production, or after-sales. Below, the diagnostic server is located. It consists of two components, the sequence engine and the communication engine. The sequence engine, also called ODX runtime, allows us to execute complex diagnostic sequences. The communication engine, also called MVCI server, allows us to execute diagnostic services. Both engines are standardized. More precisely, the ISO standard ODX and OTX. At the bottom, we find the DPDU API, a standardized protocol engine, which allows the integration of various vehicle communication interfaces and protocols in the application. For normal diagnostic use cases, this setup is sufficient. But what about the current megatrends in automotive? Everybody talks about electrical driving and autonomous driving. Both trends require a new EE architecture, including high-performance computers, the HPCs. An HPC has multiple processor cores and operating systems in parallel to perform complex calculations. An HPC is linked to a few zonal ECUs, which handle the sensors and actuators. Additionally, we need remote access in order to enable remote vehicle tests or software over-the-air updates. What is the effect of this new architecture for future diagnostics? Not only do we need diagnostics in external testers, we also need diagnostics directly in the vehicle or in the cloud. Furthermore, we need diagnostic functions for the entire vehicle and not only diagnostic services which differ from ECU to ECU. When we look again at the traditional diagnostic system, the following challenges become obvious. We have a data-dependent access, so we need deeper knowledge about the diagnostic database and even the authoring guidelines of the vehicle manufacturer. The authoring guidelines affect syntax, language, and so on. Here, the diagnostic server includes many calls, and that causes latencies. So we depend on connection quality, and that excludes remote capability. The question is, how can we overcome these obstacles? The solution is a high-performance runtime system, including a function-oriented API. Diagnostic functions for the entire vehicle are created once in development and can be reused in production or after sales. Furthermore, we have remote capability and platform independency. So the high-performance runtime system can be installed on Windows, Linux, iOS and Android. The implementation of this solution is our product, Softing SDE, the Smart Diagnostic Engine. As you can see, we reuse the existing components of the traditional diagnostic server. We can still execute diagnostic services via the MVCI server. We can still execute diagnostic sequences via the ODX runtime, but we extend these components by a simplified, reusable and remote-capable API, the Smart Diagnostic API. It allows the execution of diagnostic functions, which are identical for all ECUs. For example, if we want to read out the measurement values of an ECU, we no longer need to know the diagnostic service names. We simply ask the Smart Diagnostic API for the available measurement values. Let's have a closer look into the Smart Diagnostic API. It is also called SDA and is available for C#, C++, Java and Python. It's a functional API, and I'm going to show you a short extract of the existing SDA functions. Vehicle quick test, ECU variant identification, DTC reading and deleting, ECU programming, ECU coding, measurement values, actuator control, and so on. The SDA intelligently encapsulates several diagnostic service calls or entire sequences into easy-to-learn functions. Where is Softing SDE used? Softing SDE can be used in all kinds of tools, like development testers, production testers, or after-sales testers. Softing SDE can also be found directly in the vehicle. A telematic control unit can be equipped with Softing SDE and act as a standalone tester or programming unit with remote access. Softing SDE is increasingly being used in cloud solutions. A cloud application can be operated by the user or run automatically, like in fleet health state scenarios. Let me highlight the benefits of Softing SDE. It has an easy-to-learn API. It is used in many scenarios. It is future-proof by relying on the ODX and OTX ISO standard. And it helps to save time and costs. Now it's time to demonstrate the use of the Smart Diagnostic API. We are going to program a C# console application in Visual Studio. It reads and displays the diagnostic trouble codes of an engine control module based on a remote connection. The setup looks like this. We have a computer equipped with Visual Studio and the Smart Diagnostic engine. The computer is connected to the same network as our remote-capable VCI. Consequently, the console application has a remote connection to the engine control module. The structure of the algorithm looks like this. We create an object for the local Smart API, then we initialize the Smart API. We create an object for the remote Smart API, then we start the remote connection. We select the DTS project and the vehicle information of the remote Smart API. We load the configured interface by using the method connectInterfaces. We configure the reading of the diagnostic trouble codes. Then we read the DTCs of the engine control module and store the results in an array. We display the results in the console, and finally we stop the remote connection and end the local Smart API. So let's see the Smart Diagnostic API in action. The following video shows how to use the Smart Diagnostic API in Visual Studio with C#. The goal is to create a console application that displays the diagnostic trouble codes of an engine control module based on a remote connection. After creating a reference in Visual Studio to the dynamic link library as shown in the documentation of the Smart Diagnostic API, we can start to code. This line adds the Softing SDA library. Let's create a Smart API object called local SDA. The next step is to initialize the Smart API object local SDA. For remote diagnostics, another Smart API object, Remote SDA, will be created by using the method connect remote server on the object local SDA. Inside the bracket, we see the IP address and port of the remote server. We have just selected a Softing DTS project on the remote server. Additionally, we need the vehicle information of the project. The method connect interfaces loads the configured interfaces. The next line creates a configuration struct for DTC reading. We want to include confirmed and pending diagnostic trouble codes in our DTC read configuration. In the next line, result objects of a DTC read call will be stored in the array results. The electronic control unit that we refer to is the engine control module ECM DuAP. A for each loop allows us to go through all entries of the array results. Another for each loop allows us to go through all current diagnostic trouble codes. The output in the console is going to be display name, number and text of each diagnostic trouble code. Finally, we disconnect the remote server and end the local Smart API instance. Let's run our console application. These are the two current diagnostic trouble codes of the engine control module. Now, let's summarize our findings. We talked about the challenges of the traditional diagnostic system. It has a data-dependent access and no remote capability. The solution is a high-performance runtime system, including a function-oriented API and also remote capability. The implementation is our product, Softing SDE, the Smart Diagnostic Engine, which is used in all kinds of tools, directly in a vehicle or in cloud applications. The benefits are it has an easy-to-learn API, it is future-proof and helps to reduce costs. That was a short introduction into the Smart Diagnostic Engine and the Smart Diagnostic API. If you are interested, check out our website, leave a comment below or contact me directly. My name is Bernhard Rümpfel and I'm looking forward to seeing you in my next video.